then the magnitude of that vector along horizontal direction is called x component or horizontal component, and magnitude of that vector along y direction is called y component or vertical component. And how do we write these components? If you have a vector r making angle theta with x-axis, then its component along x direction is r cos theta, and component along y direction is r sin theta. Trick is the component which is attached to the angle theta will be cos, and the other component will be sin. Don't remember it like horizontal will be cos, vertical will be sin. It will not always be that. The one which is attached to angle will always be cos, and the other will be sin. Okay, r cos theta, r sin theta. And we discuss some examples. 10 Newton is making 30 degree. Then along x direction, its value is 5 root 3. Along y direction, its value is 5. And if you add these two components, x component and y component, then you again get the same 10 Newton force. This is the resolution of a vector. We'll see some more examples of this.
Sir,
Yes.
sir, in chat, Avani asked to explain the third question of question paper.
No, question paper we will not discuss today. Some students have not yet taken the exam. After they take it, we'll do that. Components of a vector. Very important concept. See, we are given two vectors. One is like this. This is, let us say, some 10 Newton or 10 units vector. Its magnitude is 10. And another vector is this. This magnitude is also 10. And this vector is making 60-degree angle with horizontal. Let us say this is vector A and this is vector B. Okay, now if we want to add these two vectors, how can we add? I want to add these vectors. If these two vectors were given in component form, like xi plus yj, you can easily add I to I, j to j. You just add the corresponding components, you get the sum. But here, vectors are given graphically. You can add them in two ways. One is by applying parallelogram law. You know the magnitudes of two vectors, you know the angle between them. You can apply parallelogram law. Root of p square plus q square plus 2pq cos theta. That is one way. Another way is like this. I will take, see, can I directly add A to B? No, because A and B are in different directions. If this was A and this was B, you can directly add them because they are in same direction. If this was A and this was B, you can take the difference. Same direction, opposite direction, it will be easy. But here they are not in same direction and also not in opposite direction. Then what we can do is I will take the components of vector A. Sorry, vector B. I'll take the components of vector B. One component is this, another component is this. Or I will draw like this. This is one component of vector B. This is one component of vector B. How much will be this component? It will be 10 cos 60. This component is 10 cos 60. And this component is 10 sin 60. Okay. Now, once you resolve a vector into its components, that vector no more exists, right? That vector no more exists because you have split vector B into two parts. So this will be gone. And its two components are there along x and y directions. Now, 10 cos 60 and vector A are in same direction. So you can simply add them. And B is perpendicular. You can apply parallelogram law again here. Okay. Now see how we do is,
Sir, I have a doubt.
let me complete this. Listen to a topic completely, then ask your doubts. A vector and 10 cos 60 are in same direction. Therefore, along x direction, we have 10 plus 10 cos 60 resultant, which is 10 plus 10 cos 60 is 1 by 2, which is 10 plus 5, which is 15. This is the resultant along x direction. What is the resultant along y direction? It's only 10 sin 60. Along y direction, only 10 sin 60 is there. 10 sin 60. Sin 60 is root 3 by 2, which is 5 root 3. This is the effective vector along y direction. Now, these two vectors, the situation is changed like this. This thing, I can redraw this situation like this. I have one vector along horizontal direction whose magnitude is 15 and another vector in vertical direction whose magnitude is 5 root 3. And these two are perpendicular to each other.
Sir,
That
in the
means,
along y vector, you forgot to write 10 plus 10 sin 60, sir. You directly wrote 10 sin 60.
where is that another 10 along y direction?
Sir, in along x direction, you wrote 10 plus 10 cos 16, sir.
Oh, yes. Because in next direction, already the given vector A is in this direction. Component of 10, 10 cos 60 is in this direction. So 10 plus 10 cos 60. What are the vectors acting along y direction?
Okay, sir.
So 15 is along horizontal, 5 root 3 is along vertical. Then, according to parallelogram law, two vectors are perpendicular. Then the resultant will be R is equal
Square plus q square root.
to root of 15 square plus 5 root 3 square, which is 15 square plus 25 into 3, 75. 15 square is 225. 225 plus 75, which is root 300. 100 into 3, 10 root 3 is the answer. Final resultant of the two vectors is 10 root 3. So, one point to be noted and to be understood here. In the coming topics, we will be required to add vectors, or we will be required to find resultant of two or more vectors. Then wherever you have to add, or you need to find resultant of two vectors, you first of all observe the two vectors, how they are, what is their direction. If the given vectors are all are along horizontal direction, no problem, you can simply add that. All are along vertical direction, no problem, you can simply add that. If any vector is neither horizontal nor vertical, like this vector b, it's neither horizontal nor vertical, then it will create problems for you. To handle it, what you should do is you should resolve that vector into two horizontal and vertical components. Then your problem will be, your situation will be simplified. Okay. So best way to handle vectors is you see that all your vectors are either along horizontal or vertical. Then you can add or subtract or find the resultant easily by applying parallelogram law, root of p square plus q square. This is one thing. Next, a small change. I'll take three vectors now. Okay, or I'll take two vectors only. Right, these are the two vectors. This is vector p, 10 unit. This is vector q, also 10 unit. Okay, or say 20. Take it 20. And what are the angles here? Vector p is making 30 degree. Vector q is making 45 degree. Now, if I want you to find out the resultant of these two vectors, find resultant of p and q by component method. Component method means splitting it into horizontal and vertical components. Okay, how can we do this? See, I told you, if you find any vector which is neither horizontal nor vertical, first of all, you should think that if I resolve it into components, will there be any advantage? Will the situation be simplified? Yes, here if I resolve P into vertical and horizontal components, I'll get something like this. This is a horizontal component of P. This is a horizontal component of, vertical component of P. This will be 10 cos 30, and this will be 10 sin 30. Okay. That means now vector P is gone. Vector P is gone. You have split it into two components. Okay, you should not see vector C, even though it is there. Right. Come to vector Q, 20 unit. Its component along horizontal direction is this. Component along vertical direction is this. I hope you can understand. They are overlapping. I cannot write like this because it is not vertical. They are one over the other in the same direction. Okay. This is how much is this? 20 cos 45. This is 20 sin 45. Angle attached, component attached to the angle will be cos, other will be sin. Now you should not see this vector. It's split into these two components. Okay. Now along x direction. What do I have? I have 10 cos 30 minus 20 cos 45, because towards this positive right side of origin, positive x-axis positive, negative x-axis negative. 20 cos 45 is towards left, so it is minus. Okay. Then, how much is this? 10 cos 30, 10 root 3 by 2, minus 20 cos 45, cos 45 is 45 is 1 by root 2. So it is 5 root 3 minus 20 by root 2. Don't worry about the value. Don't worry about the numerical value simplifications. They are a part of mathematics which you can easily do. Try to focus on the physics part. Square roots, addition, subtraction, all these things. We are not here to learn all these things. You know already all those mathematical operations. Basic mathematics you already know. You can do it quite well. So try to focus on the physics part, what we are doing here. Simplification is not a problem. Application of concept is the thing that you should understand. This is a problem with most of the students. While trying to learn physics, most of the students, they focus on mathematical part and they ignore or they get lost in physics. That's not the purpose, right? You are here to understand physics. Mathematics is a part of problem solving. You get it in some second or third stage of problem solving. So don't focus your entire attention on that mathematical part. Focus on what is the situation, to what concept is it related, how are we applying that concept, and how are we getting the result. That is the point you should understand from physics. Now, if I do it along y direction, I have 10 sine 30 plus 20 sine 45. 20 sine 45. Okay. If you write this step, your physics is over. The rest is mathematics. This can be simplified. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. This is 5 plus 20 by root 2. Okay. So now we have got one resultant vector along x direction and one resultant vector along y direction. What will be the overall resultant? So this situation is now like this. This situation is now like this. We have one vector along x direction, which is how much? 5 root 3 minus 20 by root 2 will be along negative. This magnitude is more. So you have this 5 root 3 minus 20 by root 2, and this along y direction 5 plus 20 by root 2. What will be the resultant of these two things? Therefore, resultant is parallelogram. Root of 5 plus 20 by root 2 whole square plus 5 root 3 minus 20 by root 2 whole square. Don't worry about the simplifications. In exam, if you get a question, the numbers that will be framed, they will be such that you will get the answer easily. I'm here just giving you for practice. So you'll get some resultant here. Okay. Is this method clear? If two vectors are given, how you find the resultant by component method?
Sir,
Uh,
sir, component method also refers to the method of addition pxi plus pxj. That method, right, sir?
you can write it that way also, but ultimately you'll do this same thing here. This
Yes, sir.
5 root 3 and 15, I can frame a vector like this resultant vector is 15i plus 5 root 3j.
Okay, sir. But my
Well,
doubt is actually, is there any special name, sir, for this process?
component method, that's all.
Okay, sir.
Okay, like this, if you are given three or more than three or any number of vectors, their magnitudes and directions, you must be able to resolve them into vertical and horizontal components and ultimately find the overall resultant. Suppose if you have a situation like this, we have a incline. This is the incline making some angle theta. And on this incline, a body is placed of mass m. A body of mass m is placed. If m is its mass, it will have weight. If mass of the body is m, then its weight will be mg. M into g. What is g? How do you get this? We will discuss in the coming chapters. For now, imagine, just try to understand that its weight, let us say it is w, and it is acting vertically downward. Weight of a body always acts vertically downward. Earth always pulls every body vertically down towards its center. So this body is being pulled towards Earth vertically downward with its weight, which is, let us say, W. Okay. Now, even though this weight W is in vertical direction, I was telling you, if you find any vector which is vertical or horizontal, it's fine. It will not make any problems. But in this situation, as the body is not on horizontal surface, but it is on a inclined surface, to understand its motion, it might be coming down, it might be sliding down, or by applying a force, you might be pushing it up. Something will be happening. Something will be happening in the given situation. So to study that thing, it will be convenient for us if you resolve the weight of the body into two mutually perpendicular components, which is one along the incline and the other perpendicular to the incline. So I will resolve weight like this. One component of weight along the incline, another component perpendicular to the incline. Just a minute. Its weight is W, acting vertically down. To study the motion of the body, I will resolve the weight into two components. One component along the incline, parallel to incline, and other component perpendicular to the incline.
Sir, weight is equals to mass plus gravity, sir.
No, you forget that thing. We'll discuss that in the next coming chapters. You would imagine W is a vector, that's all.
Okay.
W is a vector, and this vector
Then
is
what is mg, sir?
you forget this.
Okay, sir.
A vector W is acting vertically downward. Then I can resolve this vector into two components, one along the incline, another perpendicular to the incline. And if you use geometry, if you are given that this angle is theta, then this angle will be theta. If this is theta, the two components will be, this component will be W cos theta, because the one which is attached to the angle will be cos always. And the other component, this component is W sin theta. Okay. So point is, components of a vector need not be always along horizontal and vertical directions only. They can be in any orientation depending on the given situation. Okay. Or one more example. Suppose we have I am suspending a body by a string, a body of mass m or weight W. A body of weight W is suspended vertically by a string. Okay. Now what I do is I will tie a thread, or I will tie a string, another string to this weight and pull it horizontal, so that the given situation, final situation is like this. This is the final situation. The string is making some angle theta with vertical, and you are holding it like this. You are holding it like this. Now, due to weight of the body, a tension will be developed in the string. Tension, tightness will be developed in the string, and it is acting in this direction. To study the motion of this body, what we do is we will resolve the tension into two components, because tension, as you can see it, is acting along this direction, which is neither vertical nor horizontal. To understand its action easily, we resolve it into two components. One component along the horizontal, another component along the vertical. If this angle is theta, this angle will be theta. If this is theta, this is t cos theta, and this is t sin theta. So these are the practical situations in the coming chapters where we will be using this resolution of a vector. Two simple basic applications. Any questions?
No, sir.
Vectors, if you look at it from a general perspective, just say using your common sense, then it will be easy for you. If you go into the details directly, like what is cos, what is sine, what is this I, j, k, how do you write this, all these things, then you'll get confused. It will seem to be difficult for you. Vectors is a very basic thing. Vectors is like, say, your A for apple, B for boy, C for cat. To learn English, you start from there, no? First you remember the alphabet, A, B, C, D. Then you learn some simple words starting with the letters. Apple, boy, cat, dog, like that. So vectors is, you can compare it to that, A for apple, B for boy. If you are comfortable with vectors, then the coming physics will be very easy for you. 70-80% of physics we use, to understand 70-80% of the physics, we use vectors.
Sir,
Hmm.
sir, can we say a vector is a type of ray, sir, in geometry?
Ray is a representation which we use to represent a vector.
Okay, sir. Sir, but ray has infinite length, na, sir.
Yes,
But vectors have magnitudes.
they have finite lengths.
Okay, sir.
Okay, after components of a vector, next thing is we can go for multiplication of vectors. Okay, multiplication of vectors. Um, See, if you take addition and subtraction of vectors, you take addition and subtraction of vectors. Addition and subtraction can be done only on two vector quantities. Only a vector can be added or subtracted to or from another vector, you can add two vector quantities, or you can subtract two vector quantities. You cannot add one vector and one scalar. You cannot subtract one scalar from one vector. They are physically meaningless. Okay, because suppose I have a vector like this, a vector which is 4i. I can add 4i to 2j. This is okay, correct. Okay, but I cannot add 4i to just 2. This is not a vector. We don't know its direction. This is not a vector. 2 is not a vector. We don't know its direction. If you don't know direction, you cannot add them. Similarly, subtraction also. I can subtract 3j from 5j, or even 5i or 5k, something, anything. They must be vectors. This is okay. But I cannot subtract 5 from 3j because I don't know about this direction. You cannot do this. So only vector can be added to a vector. Only vector can be subtracted from a vector. That's for addition and subtraction. Whereas for multiplication, you can multiply a vector by a scalar. And in physical situations, it will give us some meaningful physical quantity. Like you have something called okay, work. Will come to that later in the coming chapters. You can multiply a vector by a scalar. You can multiply vector by a scalar, and you can multiply a vector by another vector also. So two possibilities are there. So multiplication of vectors, I can divide it into two categories. One is scalar into vector. This is one type of multiplication. Another type of multiplication is vector into vector. Okay. And when you multiply a scalar with a vector, the result that you get, scalar into vector, is a vector always. Product of a scalar and a vector will always be a vector. But when you come to the second type, vector into vector, again there are two possibilities. Product of two vectors can be a scalar. Product of two vectors can be a vector. It depends on the nature of vectors that we are multiplying. So some type of vectors, they give scalar as a product, or one method of multiplication will give you scalar as a product, and another method of multiplication gives you vector as a product. And we have two names for these two types of multiplications. The names are, if the product of two vectors is a scalar quantity, then you call it as scalar product. Or another name is dot product. What is this? If you multiply two vectors and the product is a scalar quantity, you call that method of multiplication as scalar product or dot product. Then another thing, if you multiply two vectors and the product is also a vector, then you call it as vector product. Another name is cross product. Another name is cross product. So this is what we get in multiplication of vectors. First, let us see this thing, which is simple. Multiplication of scalar by a vector by a scalar.
Sir,
Hmm.
sir, can you scroll a little bit up? Okay, sir.
Sir, I have a doubt.
Hmm.
Sir, could you give two situations where we need to multiply vectors, sir? What is the practical use?
Even if I give the examples now, you might not relate the quantities. We have some quantity called work in physics.
Yes, sir.
Sir, forcing to
Work
Force.
is defined as the product of force and displacement. Force, technically speaking, is a vector quantity. Displacement is a vector quantity. When you multiply these two vectors, the product work which you are getting, it has no direction. From physics point of view, it has no sense of direction. So this is a scalar. When you are multiplying one vector with another vector, you are getting a scalar as the product. We have something else called torque, which you get in rotational motion.
Yes, sir, in a cars.
Uh, it is defined as the product of perpendicular distance and force. Position vector and force. Position vector is a vector, force is a vector. When you multiply these two things, you get some physical quantity called torque. And this torque is a vector. So when one vector is multiplied by another vector, the resultant is a vector.
Okay, sir. Thank you, sir.
Multiplication of a vector by a scalar. Simple. If a vector is multiplied by a scalar quantity, then the product is always a vector. For example, I have vector A, which is 3i minus 2j plus k. Then if I multiply vector A by 3, 3 is a scalar quantity, number, just number. 3 into a vector will give me 3 into vector A, 3i minus 2j plus k, which is 9i minus 6j plus 3k, which is also a vector. If I have another vector B, like minus I plus j plus 2k, then I will do minus 2a. I am multiplying that vector B. I am multiplying vector B with a number which is minus 2. I'll get minus 2 into minus I plus j plus 2k. Minus 2 minus I, 2i, minus 2j minus 2j, minus 2 into plus 2k, minus 4k. That's all. There is nothing new here. It's just like opening your brackets in case of your ordinary multiplication. So multiplication of vector by a scalar is nothing complicated, simple. If you take multiplication of vector by a vector, okay, we get two situations, but I think we cannot complete that in this class. Okay, just a minute. We'll look for some questions. Okay, you tell me how you do this. Vector A is 2 centimeter long and 60-degree above x-axis in the first quadrant. Vector B is 2 centimeter long and 60-degree below x-axis in the fourth quadrant. Find A plus B. Try this. You have 2 minutes time. Read the question, understand, draw a figure, try to solve.
Sir, 60 degrees above x-axis means making an angle of 60 degrees with x-axis. Okay, sir.
Sir, A bar plus B bar equals to 2 I cap, sir.
2 I cap. 2 I cap. Yes, right. It is correct. Good. Two I cap is the correct answer. Resultant of those two vectors will be 2 units, 2 centimeter along positive x direction. So see whether you get it or not. It's the same thing that we have done in our previous examples. It's the same model of question.
Sir, I got a 2I cap plus root 3 plus root 3 j cap.
No. You
R
don't.
sine.
You should find the
Oh,
overall
okay,
resultant.
sir.
Sir, can you explain it?
You try it. You try it. If you don't get it, I'll explain it tomorrow.
Okay, sir.
If you don't get something in the first attempt, you make a second attempt, you make it a third attempt, and even after so many attempts you don't get it, then you should take some help. Otherwise, the best thing to learn is to do by yourself. Refer to the examples that we have discussed in this class, today's class, and understand them clearly, and again come back to the question. Okay.
Okay, sir.
Continue tomorrow. See you and good night.
Thank you, sir. Bye.